Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching with me live or you're watching the recording, I appreciate you watching wherever you might be. So today we're starting to talk about Git. And before we get into that, just a couple of announcements that we have here today. One is, don't forget that on Thursdays we have our study hall, room 3200 here in the Fa22 building on campus. I'm in there just in case you need help, or if you just want to come in there and work for whatever reason. I'm also monitoring Teams during that time. So if you want to, jump on Teams and talk at that point, you can do that as well. Right? It's an entire day for us to have some opportunities to, so I can give you some one-on-one help, answer your questions, whatever you need to do during that day. And so that's on campus in room 3200 of the Fa22 building, or virtually via Teams. Also, just a quick reminder up front here that this is a 2-week module. So it won't be due this Thursday, but it'll be due next Thursday. So not this Thursday, but next Thursday. So we still have plenty of time to get our stuff together for Git here. We're going to talk about a little bit of Git today, what Git is, why it works. And we are going to set up Git and maybe do a thing or two with it. Just so we can kind of work with that. So we'll get started kind of defining a few things and looking at why Git is important. And you might hear, Git, right? And, it's like, what is Git? Right? You might have a relative that'll go, get away from here, right? But we're not talking about Git in that sort of way. We're not talking about a Git stick, as you see here, to drive something away. But we are talking about a version management tool, a version control system, which we can also call source control management, since it's programming, right? We're working with source code. We're able to deal with source code or source text, and we're able to control different versions and make sure we have different things that we're working with and that we're putting together and all that sort of fun stuff as we're working with Git. So Git is source control management. And we can use this locally on our own machines, and we can also use it in conjunction with a server, and that's what GitHub is, which we'll talk more about next week. So this week our goal is to just talk about what Git is, what it does, get it up and running, maybe show you a brief demonstration about what it can do, and that'll be what we do today. But the big thing about Git is that it's distributed architecture. Right? Git is working across multiple systems. So if we're able to send things to GitHub, we also have a version that's on our machine, and everybody working with us has a version on their machine. Right? So every developer that is working on a singular code repository has a version that can contain the full history of changes. And that's one of the great things about the Git as a concept, right? As we're using it, we're not just seeing the work that we've done, but when we get our pulls and our pushes and we send our code around to different places and, push it to the central repository and pull it back down, we're able to see everything that our colleagues have done. We have the entire history of that document tied to what we're working on there. So everybody has their own version that belongs to them, and everybody's own version that belongs to them contains the entire history of changes that everybody has put into that code, which is incredibly useful, right? Which, why would we use a version control system at all? And the first thing is that code's an iterative process. Right, one of the things that we talk about in programming classes, since pretty much all of you have taken programming classes with me before, is that we first want to make it work, and then we want to make it better. So if we create a version of our program every time that it works, and we take that and push it to our central repository, then we have a working piece of code that we can refer to. So then if we make changes, if we make edits, if we do things to it that break the code, then we can revert it back. Right? And that's a version control system in general, right? There are all sorts of different types of version control systems. What makes Git a better version control system than a lot of the other ones that we've seen is the fact that everybody has their own version of the code, and everybody's version of the code has the entire history if they pull it down. Right, so you can create new versions or new snapshots of your code as you're kind of working with it, push them to a repository, and you have a history that you can go back and look at and see the changes that you've made. You can make mistakes without having to worry about, needing to completely start over. You can just go back to the last good version and pick up from there. Right, so we can almost look at it as like a type of Super Saiyan Control Z. Right, it gives us the ability to go back, but it also gives us the ability to go back to a good state with other people's code that they've contributed to the project and not just our own. Right, there's a lot of powerful stuff going on with Git here, which we really, really like. When Git was created, it was created by an individual who you might have heard of before, Linus Torvalds, who was also the creator of Linux, right? Created Git in around 2005. Right, so the idea or need for Git came among came out of the Linux development community, right? Since Linux is open source, you have multiple different people, dozens, maybe even hundreds of different people working on a specific repository of code, a specific set of code. So we have to be able to do version control on a singular repository wherein dozens or even hundreds of people can have access to all of the changes that get made to that central repository of code, so that everybody can have the most up-to-date, current, working version of the code as they're continuing development themselves. Right, and so, Linux being a huge open source project, right, the Linux kernel in particular being an enormous open source project that tons of people are working on all the time, we had this need here for the ability for all these people to work. And we can actually see the Linux kernel on GitHub, where people are able to clone the repo and make changes to it and work with it. Right, this is the Linux kernel. We can see here that it is in. And we'll go to full screen here so y'all can see this a little bit better. We can see here that it is in Linus Torvalds' directory. Right, it's in his repositories. It's part of his repositories, which is something that you all will be doing as you're working on your final projects. You'll have one person that's responsible for the repositories, and then another person, or the rest of the group, that's able to contribute to the central repository. If we look at the history here, we can see there's been over 1 million commits to the Linux kernel, and we can click this and we can see the entire history of commits to the Linux kernel, many of them being made by Linus, but we can also see some other ones being made by other users here as they're merging pull requests, which we'll talk more about that next week, as they're merging pull requests into the code base for the Linux kernel. And each one of these commits here that we see in the history is a version, right? And if we look here to the right, we see this button here. That is the commit number, which we could also look at that as a version number. So if we click that, we can see exactly what was changed in this commit as we made a new version. And in this particular one I clicked on here, we can see it's in the it's for AMD-based GPUs. It is a .c file, so it is in the C programming language. And we can see the changes that they made here. They changed this conditional to read PSP instead of ADEV. And then they included another conditional for another item where there wasn't one previously. Right, so we can see the side-by-side comparison of the things that has happened in this change. We have a record of that, and as other people are working on it, they can pull these changes and have these changes as well. There's what it looks like unified there. So it's pretty interesting as we're working with this. You know, we can go into basically any GitHub that we see and see this history. And this history is a good visual for how Git works, because we're creating all of these commits are a version. But again, we'll get more into about how GitHub works next week as we're sort of progressing through this and learning about Git and GitHub. So next week we'll be pushing stuff to GitHub, and we'll be doing pull requests, and we'll be doing all that sort of fun stuff next week. But this week we're continuing on with Git. So how exactly does Git work? Right, so there was a time when if we were going to be working on a singular document, only one user could really work on a singular document at a time. Right, you might have experienced things with, say, an Excel spreadsheet before. If I have an Excel spreadsheet on my desktop and I need somebody else to be able to make changes to that, I have to save that file, I have to close that file, send that file to them in an email, and then they have their own version of the file. Right? So if they make changes to that file, they have to save it and send that file back to me, and then I can either delete my file or maybe copy and paste information out of their file or something, right? But either way, there's a checkout process there. Right? As somebody goes to get that file, they are checking it out to where nobody else can really work with it, making the changes that they want to make, and sending it back and checking it back in. Git doesn't work like that. With Git, again, you have your own clone of the code, and you pull the changes from your repository. Again, that'll be something that we do next week as we get more into GitHub. And everybody's copy, everybody that makes a copy from the remote server is just as good as anybody else's. Right? Meaning if you have an up-to-date pull of your copy, you have the exact same copy of code that everybody else who's working on the project has. So as you're working on it and making changes to it, if you're submitting and committing those changes along the way and then making pulls regularly to get the most update changes back to you, you have the exact same thing that everybody else does. Which is absolutely incredible when we think about where we've come from to where we're at now. Right? When we think about where we come from here, you know, checking out a file and working on it and then checking it back in. Versus everybody having the most up-to-date file, everybody being able to work on the file simultaneously and being able to send in their changes, and then they get merged into the main repository, which then allows you to pull the changes back out without having to rely on anybody else, wait on anybody else, right? Everybody can just kind of work at their own pace, doing their own thing. and just sending a couple commits as necessary, right? And so most of the operations that we'll do in Git are local. They're done on your machine, right? So we can make a bunch of changes locally without having to do a push. Right? We do some checking in and checking out from the local repo. We can do some commit changes. We can do some various other things, right? And our local repo keeps a version history. And then when we push our local repo's version history to the server's version history, it merges them together, which is why we call it a merge, and puts them into one thing. Right? Which is really, really useful when we're all working on the same code. You know, we don't have to be in the same room working on it, or we don't have to, you know, even really know the people that we're working with, right? It's one of the interesting things about GitHub and open source projects is I can get on an open source project. I can see something that needs to be done. I can make that fix. I can send it back. And everything's cool. Right? They don't have to know me. They don't have to know who I am. They can see my code that I send back to them, and they can say, well, you know, this works. This fixes our problem. Or this doesn't work. This doesn't meet our needs. And so they can choose to merge the pull request or not. Right? Which is pretty good. To give kind of a visual here of what's going on when it comes to, you know, Git. We can see here computer A and computer B. We can kind of think of these as two different people who are working on the same project, right? So they have their own version of the file. And they have a file version database on their local machines. Well, that version database is the data that's shared with the server computer and in turn shared with the other users as we're making pushes and pulls. Right, so computer A and B here, they're on the level. Right, these two people here. Computer A has their file. Computer B has their file. These two files are equivalent. Right, they are equal. They are equally important files. They might have some local changes that make them different. Right, but they are equally important files because they all have the same, they all refer back to the same version database. So they all have the same history of versions that is related to them. The same thing that's on the server. And so when I get a new project done, I can commit and push my changes back to the server, and if those changes get added in, it would add a new version to the version history. And so these version databases, whenever I'm doing pulls, they all communicate with one another. You again get your own copy of the most up-to-date database. You're able to work with it. You're able to do what you need to do. So let's look at a little bit of a basic Git workflow here. And we can kind of visualize this as well. Typically what we're going to start with is we're going to create a project in some folder on our computer. So we're just going to make a folder somewhere. And inside of that folder, we're going to tell our version control system to track the changes. So this is a Git init. We're going to initialize Git in just some random folder on our machine. And so when we initialize Git in a random folder in our machine, what that tells the software to do is, hey, listen for changes. Listen for any changes that might happen in this folder. Listen for any changes that might happen in this folder and help me keep a record of them. That's what we're going to do here with our version control. We're going to just keep track of changes. And so each time your project is in a working state or you're getting ready to walk away from your project, maybe for an extended period of time, you're going to tell your version control system to take the state that it is currently in and make a version out of it. Right, so you're going to make what we call a new commit. And so as we're making a new commit, we're going to just kind of stage everything into, everything that we have in the folder. We're going to stage up all the changes, any new files that were added, any changes that were made to any of those files. And we are going to create a commit with those, and it's going to create a version in our version database. So then if we need to revert back to that version in the future, we can. If we make some new versions from there, that's fine, right? It's going to keep that entire history of all the different versions. We can use whichever previous version we need to get the job done, which is incredibly useful. And again, just so we can have a visual here, doing this kind of visualization. We have a working directory. That's our folder on our computer. Now, before we run the git add here, our git commit is somewhere over here. Or rather, our git init, not our git commit. Our git commit is somewhere over here. Because in order to have a working directory, we need to initialize git. We need to put git in it so that git can listen to the changes that are going on inside of this folder. Right, so once we have a folder, which is our working directory, we use git add. And git add is when we tell it which files and or folders in our working directory that we want to stage. Right, so we're basically taking all the files in our working directory and we're putting them into a singular staging area so we can kind of prepare a version. And so typically when we do this, we're going to git add period. Or since I know this text works now, right, that is git add period or git add dot. Right, the dot here would be a wildcard selector for every file. So if we're going to stage a new version to put into the staging area, then we're going to git add dot. We're going to add every file that's in our working directory to the staging area, but we haven't saved it yet at that point, right? We haven't made a version out of it. We've just taken everything we need and we kind of put it into one package. Then when we run our git commit on it, at that point, we've created a version out of it. So we initialize git in a working directory, git init. We put git, one of the things that I'll say instead of, git initialize, right, just as a mnemonic for us to kind of remember it, I say we're going to put git init. So in order to put git init, we need to run git init in our working directory. And we'll actually see that it actually does put git init when we do that in just a little bit. From there, we do any work that we need to do, right? We create any files, we make any changes to files, we do kind of whatever we need to do there. From there, we run our git add command to stage them, and git commit creates a version in our local repo. When we're ready to take what we've done locally and push it to our server, we can use git push. And that's going to be for use with GitHub, right? So we'll do more of that pushing and pulling next week. But you can also see down here on the bottom, we have a Git checkout. And when we check out a version in Git, we are taking it out of the local repo. We're checking a version out of the version database and bringing that back into the working area, effectively overwriting what we have there if we didn't stage and commit the version that we're currently working on. Right, which is incredibly useful for us. So I think the best thing for us to do is just to kind of take some time and work through some of this. So what I'm going to do is I am going to go to just do the entire process of getting and installing Git. Here's our website to get Git. git-scm.com. I have the download for Git for Windows right here. Git for Windows is a separately managed version of Git outside of the regular Git for Linux and Mac. But it is the same code that's just been ported over to Windows. So I can download it here. You can get a choice of a standalone installer, 32 gigabyte or 64 gigabyte. You can also get a thumb drive edition, which is incredibly useful, you know, when we're thinking about portability of code, right? If I have a portable Git that I can install onto a flash drive, then code becomes infinitely more portable, because basically everywhere that I can have my flash drive, I can work on code, and I can use the Git portable version that I have on my flash drive to be able to pull and push and commit and do everything that I would need to do with everything else. So here at the top we see click here to download the latest 64-bit Git for Windows. I am on a 64-bit system, so that's exactly what I'm going to use. We can see that this version was just released 2 weeks ago at the end of August, right? So, you know, new code that we're working with here. And we're going to save it in here. And I've already saved it. I was just doing a little bit of testing there. But now I can go and I can open up my executable by just double clicking on it. And in fact, you know what I want to do? I want to make this a video to put in the module. So you know what I'm going to do? I'm going to back up just a little bit, do that again. And I'm just going to kind of re-intro myself to be able to do this. So that way I can just cut that out of this video and put it in the module. So I can say, hello everybody, in this video we're going to be taking and installing Git for Windows. Here, as we can see, we're on the Git website, git-scm.com. We'll zoom into it here at the top so you can see that a little bit better. That's git-scm.com. And we can see here on the homepage of git-scm, we have the best version for us to use here, available as a download. Mine's a download for Windows. We can see here that it was just released on August the 30th of 2022. It is the current stable release, version 2.37.3. So I can click here on the download for Windows, and that will take me to a separate page. At the very top of the page here, we have a link. Click here to download the latest 64-bit version of Git for Windows. I'm on a 64-bit system. If you are not on a 64-bit system, if you're only on a 32-bit system, you'd want to get the 32-bit Git for Windows set up. But I'm going to save that into my downloads folder. And from there, I'm just going to give it the old double click. to open my executable. So here's my Git setup information. And all I'm going to do here is I'm just going to follow everything it says. When we need to do something a little bit different than just the default, we'll stop there. But I'm going to next. Next. If we want to install some other stuff here, we can do that. I want to add this Git bash profile here to Windows Terminal. I'm going to show you all how to do it without Windows Terminal. I think it's easier that way for people who are just getting started. But I think that's fine. If you wanted to have it check for daily updates, you can click that box there. I think everything else is pretty good by default, so we can just go with that. We're gonna install it in a directory named Git. Our text editor here, and this is going to be, based on you, right? If you want to pick a text editor here, you're able to do so, right? Like I use Visual Studio Code as my default code editor, and Visual Studio Code also has the Git version control built into it. So I might want to use Visual Studio Code here as my default editor. You can leave it as Vim, which is what's shown by default. It's not going to mess anything up. It's not going to change anything. Right? But I can go ahead and put Visual Studio Code as Git's default code editor. So we can let Git decide for the branch name. By default, it is master. If you want to change it to something else, you're welcome to do that. We're just going to want to remember what it is here. And so I'm just going to keep mine as the default branch name being master. We'll see what that means when we get more into Git and how we can build branches and forks off of projects. But it's just by default, any new folder that we initialize Git in will be called the master branch. So here we have how we're going to use our path environment here. Use Git from Git bash only. Will not modify your path. So if you do this, there is a way that we can work with that. And it's actually going to be something that I'm going to be showing you when we get to that point. By default, it goes to the center one here, Git from the command line and also from third-party software. So that will allow you to use Git bash and also things like Visual Studio Code to be able to send Git commands. But you'll also be able to use the command prompt and PowerShell and anything else. So this gives you more options than just the standard Git and Git bash. But this also creates an environment variable, a path environment variable. And sometimes if this gets a little wonky, you might have to change the path environment variable. But it should do it for you on its own. I'm going to use the bundled OpenSSH that comes with it. I'm going to use the OpenSSL library that comes with it. So how should Git treat line endings in text files? The default here, check out Windows style, commit Unix style, is typically what I stick with here. I don't know that any of these would really make a huge difference in terms of your setup, but we're going to stick with how it comes. We can leave that where it is. That just gives you a terminal emulator for Git bash. Default behavior of Git pull is exactly what we want. We're going to use the cross-platform Git credential manager to help us save our credentials. Enable system caching is fine. Don't really need either of these experimental features. And it's going to run the install from here. And so that will install our software. And just like that, we have Git on our system. Now, you can look at the release notes if you want to. I'm not gonna. One thing that I am going to do here is go ahead and launch Git Bash. And so this is Git Bash. This is the command prompt here that we see. We can do some, if we right click in the window, we can go into our options here. One of the things that I usually do, since I do this, since I work with this on video, is I will go in and make my font larger. So we see here that by default my font is Lucida Console 9 point. If I select, I can make it bigger. I'm going to go 22 point and apply. You can also pick a different font if you want one. We might, I've always thought about maybe working with a different console font, but Lucida Console is kind of nice, so we're just going to stick with it. And that's going to blow up my window by default because it's making it bigger for the big text, but I can shrink it back down if I want to, right? I can just grab a corner. Let me try this other corner. I was trying to click it to where it wouldn't accidentally drag it or accidentally close it. But I can grab a corner and drag it to make it as big as I want to make it. Right, and you can kind of go through the settings here and see, see what you want changed, kind of customize it to your liking. Right, since mine's bigger, I'm going to go in here into the window and choose rewrap on resize. So I can shrink it down and everything will still work nicely. And it's all well and good. So now I have Git, we'll apply, and we'll save, and we're good to go. So now I have Git on my system. So now one of the things that we can do is we can jump into our course from here. So let's do that. Because from here, we can kind of go through our setup process the way we have it laid out here in setting up Git. We're going to want to set up these configs. And so they're pretty simple, right? We're just going to set our global username. We're going to set our global email. And we're going to set our global UI. So if everything's working properly, we should be able to run our git command. One of the things that we might want to do first is maybe just run a git version just to make sure everything is here, right? And so if we run git version, we see that we're on git version 2.37.3.windows.1, right? So that just shows me the version of Git that's on my machine. If I can run from that or from a Windows command prompt, cmd.exe, if I can run from this Git version, it should give me the same thing, especially if I can run it from my Windows command prompt and get the version back, then I know everything's installed correctly. But we're going to stick in Bash here. And so from here, I'm just going to run these little configuration commands here. I'm going to actually put my name and my email address in here instead of Mr. Vlad Dracula's there. But we're just going to run git config -- global user.name, just the username that I want to put in there. Could be your whole name, could be your screen name that you're using for GitHub, doesn't really matter. And we'll hit enter, and that will configure that. Now we'll set the user global email, git config -- global user.email. and my community college email in quotes there. Git config -- global color.ui. So by default here it's auto. Let me actually get my list here of Git UI colors, because these are just color UI themes, right? So if we actually look in our if we look in some Git config documentation, then we can see some different color UIs that we can play with. And we can also switch it to false here, which would turn the color off, right? So there's a lot of stuff that we can work with here. Setting it to false will disable all the colors. I don't recommend doing that. We can set it to something like, green. Right, and that'll change different things to green. I like keeping mine, though, at the default or auto UI interface there. I like the colors. But you can look at some documentation that we have for that if you want to change that. So now basically I have Git and it's ready to run on my machine, right? I'm ready to initialize a project and work with it. So what I'm going to do, just to kind of show you all this, is I'm going to go ahead and close this window, because I want to show you all the way I like to start my Git projects. Right, so I'm going to get myself a new window over here. Let me get into my Web 140 folder here and create a new Fall 2022 folder. So from here, I can basically kind of follow the instructions that we have here, right? And work with my stuff that I have going on here. So I'm going to create a new folder. We'll call it Git Project 1. And so now I can go inside that folder. So I'm just going to enter that folder. From here, I'm going to right-click my mouse just in the empty space in this empty folder. And you can see Git GUI here, Git Bash here. I'm going to go ahead and click Git Bash here. And I do that because that automatically, I don't have to worry about, using the CD command or the dir command to change directories. It just opens right in the folder that I'm working in my project. And so from here, I can enter the git init. I can put git in it, right? I can enter my git init command. And boom, enter. I've initialized empty Git repository in this particular folder. Right? And if I look in that folder, I can see right there it is. Right? I said it puts Git in it. So if I have my hidden files checked, it shows it to me. If I don't have my hidden files checked, it's hidden. I'm going to go in here in my view tab and make sure that I have my hidden files checked. And that shows me that Git is in the directory. And if we go in there, we can actually see some of the code and stuff that it's put in there. We don't want to mess with any of this, right? Because it's kind of important for all this to function. But we can kind of go in and look at it just to see that it's there. Right, so now what I can do is I can just use this this Git Bash here just as I'd use a terminal, right? So I could make a new file from here. I could create a new file from in my Windows GUI here. Doesn't really matter. I could do it in Visual Studio Code if I wanted to, right? The way we've done things previously. So just for our purposes, just to kind of do what we're doing here, I'm just going to create a file from the command line here just so we can see that we can do that. So we'll just run an echo of, we'll say sample text in a file called test.txt. Right, so now if we look at that folder again, there it is. I have test.txt in there. I can open it up. I can send my sample text right in there. Right, since we're just doing this basic example here. So what we can do from here is we can run a status check. If I want to see what's happened in my folder, or if I want to see, if I have a commit stage ready to be committed, or if I have some new data that needs to be committed, I can check it with a get status. So I can run get status. Ooh, bad Boolean config for color UI. Let me fix that. That should actually be, I think that should actually just be true. There. Now I can use get status, and it shows me what's happened here. Right? When I run get status, I see that I'm on branch master. Right? Remember when we set our software up, we said, okay, we're going to leave this box checked, so our initial branch is going to be master by default. There are no commits yet, but there is a file that's currently being untracked, which means it hasn't been added to the staging area to track it. So it tells me that I need to use get add to track it. So I can run my get add period. Remember, adding the period there is like basically saying get add everything. And hit enter there. Tells me that LF will be replaced by CRLF. Those are those line ending things that we talked about. That's not a huge deal. Right? That is just fine. And so now it's staged. Right? We took it. It's in the folder that's being tracked. We looked here and it says, okay, we got this new file here, but it's not staged yet. We staged it by adding it, get add period. So if we run get status now, we see that we're on branch master. We don't have a commit yet, but we have a file that's had some changes made to it that we can work on. Right? New file, test.txt. And so it says here I can use get rm -- cached and then the file to take it out of the stage. But I don't want to do that. I want to add it to a commit. So I'm going to go get commit -m. -m here is for -message. And then in quotes, I want to put some sort of message to, let me know when I'm looking back through my version history what this commit was. And so most of the time when you look at GitHubs and things, the first commit message is initial commit. Right? Because it's the first time we've sent code into, a committed area. First time we've made a version of the code. So we could put initial commit. We could put first version. We can put whatever we want between those quotes there. That's more so a message for us than it is a message for anybody else. Right? Because when we're looking back through our version history and we want to see, at a glance what we changed, That's what that message is for. So when we hit enter there, we see what happens, right? Git commit -m first version, master root -commit. It gives us this ID here, 43BEBLA, right? That's the identifier for that commit. And it has first version, which is the commit message that we made there. Tells us we had one file changed, one insertion, create mode. And so now if we look at get status, it should tell us that there is nothing now, since we've done a commit and we've already made a version copy and nothing else has been changed. Right? So that's exactly what it tells us. On branch master, nothing to commit, working tree clean. So nothing's been changed, right? Our git init is still listening for changes to be made. Nothing's been changed, so my working tree is clean. If I look at git history, or no, it's not history. What is it? Git log, that's what it is. Or no, git show. Git show is the command I want to use for you all. Git show. Or, yeah, git show master. Yeah, there we go. So this is everything that's happened in the master, right? We see we have test.txt. And then we can also run git log. And that will show me my entire version history. So git history, git log. All right, so we can see here that 43, when we looked up here, and we got that 43BEBL1A. If we look at the commit log here, 43BEBL or B1A, that's a 1. That's the first 7 characters of this entire long hash here. And so you only need enough of the hash for Git to know what it is, to be able to check it out. Right, so if we go back and we look at that screen that we did here, we did our git add, we did our git init, we did our git add, we did our git commit. And so the only thing we need to do now is a git checkout, right? So in order to do a git checkout, we need another version. So let's head back to here, here, and here. Let's get this file. So now I'm going to go into this file and I'm just going to add some more text. I've added some more text to this file. Imagine it's code or something. Right, we can save that and close it. So now this file has changed. So if we run git status now, git init should have picked up on a file change. Right, it happens almost instantly when we're dealing with, you know, such a small amount of files here. So git status should have seen, yep, we have a modified file here, test.txt. So we need to git add again. So we're going to run our git add, period, to add every file in the directory. And okay, it says it's been added. We can run our git status again just to make sure. And we can commit it. Git commit -m added more stuff in between quotes. And it'll run my commit. So now I see I have a new file here. And if I go back over here, you know, it has that new data into it. But maybe I made a big oopsie, right? So I can look at my git log. I can see all my versions. Git log. And so now I've made this new version, and instead of 243C022, which we have here, I want to go back to this one, 43BE B1A. So I can get checkout 43BE B1A. And that will check out the old version of the file. That will revert my file back to this version. And it tells me, okay, now I'm in a detached head state, which means I can look around, I can make experimental changes, and I can commit them. And I can also discard any commits that I do in here. Right? If I go back here and I look at test.txt, that other text that we added is gone. So it's reverted it back to where it was before that 243C022 version. Right? It had this version of the file saved. And so now I can add some different text, and I can say like, oh, I actually wanted to add this instead. My mistake. So since we're in a detached head state here, we need to make a commit to get back into it. If I want to have this on a separate branch, I can create a new branch here. Otherwise, what I need to do is just run a git commit. So git commit -m changed some, or actually I need to run git add first. Git add period git commit -m added new stuff. And it says, we're on detached head, added new stuff. And so if I show my log now, get log, we can see I have this new version here. It is now my head. Everything's back to normal now. That version that we reverted is gone since we went back over it. And those are the basics of Git. Right, if we look at our file now, it's saved there. I can go back and look. It's got that new text in it. That old text is gone. So these are the basics of Git. Next week we will discuss how to upload this to GitHub, among other things, right? We'll be working more directly with GitHub next week. We'll do a little example where I do like some pull requests and things like that. We'll spend a lot of time working with Git next week. But we've basically hit our 1 hour mark, so I think that's all the time that I want to put into this today. We'll hang out with the music on for just a couple minutes here, just in case anybody who is watching with me live has any questions. If you are watching the recording and you have questions, feel free to email me and let me know. Git is a whole lot simpler than it looks. We're going to use it for every project from here on out. So we'll get really accustomed to it by the end of the semester. That's all that I have for you for today. Thank you for watching, and we'll see you next time.